Space, the last great unknown. NASA's mission to unravel the mysteries of mankind's final frontier, to search for new knowledge and understanding. Godspeed, John Glenn, and to lead us towards a peaceful and unified future in space. The vehicle has landed. This two-part film will explore 10 of NASA's greatest achievements in space and science and reveal how they are responsible for continually shaping the way we live our lives on Earth and how we view our place in the universe. That's one small step for man, one giant leap for mankind. Human beings can turn their attention to the most improbable and the most audacious of endeavors. It was the essential first step to get an American into space, and it worked. The International Space Station truly is a wonder of space engineering. The Hubble Space Telescope is a unique instrument. Pathfinder did suggest that Mars may have had life early on in its history. With the right amount of money, the right amount of skill, and the right amount of public support, we can do anything and go anywhere. For the eyes of the world, absolutely incredible. Now look into space. Okay, here we go. To the moon and to the planets beyond. Lift off, and we set sail on this new sea to solve these mysteries. To solve them for the good of all mankind. When the Soviets launched the Sputnik satellite in 1957, great concern was expressed by the US government about the technological superiority of their Cold War enemy. It was clear that a federal organization for spearheading American space efforts was needed, and in 1958, the National Aeronautics and Space Administration, known as NASA, was born. But despite its Cold War genesis, NASA formed as a distinctly civilian agency with a focus on the peaceful exploration of space and science. President Eisenhower wanted a space program for science and technology that was not based on the military occupation of space. And his emblem was Space for Peace. He was deeply concerned that if left to their own devices, the military would occupy space and take the high ground. Had that occurred, you would never have seen any of the great accomplishments in science or engineering that embraced the world. And enshrined in NASA's mandate is international cooperation and the free sharing of scientific data. Impossible if the military were running the space program. Thanks to Eisenhower's forward-thinking administration, NASA has been the world's leading manned and unmanned space research agency since the late 1950s, setting the precedent for all present and future spacefaring nations. Music, ladies and gentlemen. Today we are introducing to you and to the world these 7 men who have been selected to begin training for orbital spaceflight. These, ladies and gentlemen, are the nation's Mercury astronauts. On April 9th, 1959, NASA introduced to the world the astronauts-selected tow pilot Project Mercury, America's first manned space program. Known as the Mercury 7, these men immediately became national heroes, ready to race the Soviet Union to space. Project Mercury's first goal was to put a solo human into Earth orbit, and the first mission assigned to attempt this goal was named Freedom 7. Freedom 7 was America's first foray into human spaceflight. And it came at a rather difficult period in time because 3 weeks before the launch of Freedom 7, Russia had successfully launched Yuri Gagarin, who became the first human in space. The US was already lagging behind in the space race, giving it a rather negative image internationally. So it really needed a good news story, and Freedom 7 gave it that story. Of the Mercury 7, astronaut Alan Shepard was chosen to become the first American to fly in space. He was to pilot the Mercury Redstone launch vehicle, a hybrid of a US Army ballistic missile and a research and development rocket modified for human flight. Finally, on May 5th, 1961, Al Shepard left Cape Canaveral and led the United States into a new era of manned space exploration. Flight, this is EMO. Go ahead, EMO. All subsystems start green. Roger M. Understand all systems green. It's 60 seconds. Counting down, counting. Status check. Pressurization. Rocks tanking. You are go. Water systems go. T-minus 30 seconds. Mercury capsule. No. All pre-op panel lights are correct. The ready light is on. T-minus 15 seconds. Mercury umbilical clear. Mercury lights on. T-minus 109876544321. Engine start. Ignition. All right. Liftoff, and the clock has started. This is Freedom 7 reading you loud and clear. The fuel is go. 1, 2, G, cabin. At 14 pounds per square inches. Oxygen is go. All systems are go. Music. Freedom 7 with astronaut Alan B. Shepard reports. The fuel system is go. Oxygen go. All systems go. Astronaut Alan B. Shepard is working like a test pilot, reporting facts and figures, reporting procedures in the precise engineering manner of a test pilot. Music trajectory looks a beautiful view. Freedom 7's suborbital flight lasted 15 minutes and followed a parabolic trajectory, arcing over the Earth's surface to land in the ocean 302 miles downrange. The main scientific objective of Project Mercury was to determine man's scapability in the space environment and the conditions under which astronauts would have to work. In contrast to Yuri Gagarin's flight, which was effectively an automated flight, Gagarin had the ability to control the spacecraft, but Shepard's flight allowed him to exercise some control over the spacecraft. Pilot reports assuming retro attitude, initiating retro fire sequence. Pilot reports mission very smooth. During the early phase of the mission, he was able to take control of the spacecraft. He was able to fire the attitude control thrusters to control the orientation of the spacecraft. He's going to hand control movements now, switching to manual control of the pitch attitude. So Shepard genuinely took real control of the spacecraft. He wasn't just there for the ride. He wasn't simply baggage. After re-entry, the capsule of Freedom 7 landed by parachute in the Atlantic Ocean, with Al Shepard paving the way for very NASA astronaut and manned mission to come. The US were desperate to get into space with Al Shepard. It was a suborbital flight, but it took an awful lot of courage from him for the other people involved, and was clearly, it's right at the beginning like that. It seems so basic now to be sitting on top of what is basically an intercontinental ballistic missile land, like the blue touch paper, run and collect him at the other end. But it was the essential first step to get an American into space, and it worked, and it was a phenomenal achievement for him and the team. The initial Mercury manned spaceflight certainly helped lift the spirits in America of people who felt that the Russians were racing ahead, that they'd been eclipsed with Sputnik, they've been eclipsed with Gagarin in the first months of a president who had criticized the government it replaced for sitting on their hands while the Russians romped away into the future. So it was vital to restore American pride and to mobilize a can-do spirit so that weeks later, when Kennedy announced the decision to go to the moon, people could believe it. I believe that this nation should commit itself to achieving the goal before this decade is out, of landing a man on the moon and returning him safely to the Earth. Freedom 7 was a vital component of Kennedy's moon program that had been decided before Alan Shepard first went into orbit. And in fact, the announcement of that decision was held back until Alan Shepard's flight on the 5th of May, 1961. Freedom 7 had to happen for Kennedy's commitment to go to the moon to be publicly announced and to be a funded program. Otherwise, we would probably not have been on the moon even yet. Freedom 7 was only the beginning of Al Shepard's spaceflight career. He later served as chief of the Astronaut Office Music, and then in 1971 flew to the moon as commander of Apollo 14. Okay, Al, we can see you coming down the ladder right now. Old man, it's been a long way, but we're here. Human spaceflight has changed dramatically since 1961. Today's flights are complex, multi-crew, multinational missions working together in the spirit of international collaboration. But the legacy of Freedom 7, Al Shepard, and the pioneering Mercury project will be remembered every time NASA launches humans into space. Godspeed, John Glenn. Roger, the clock is operating. We're underway. Oh, that view is tremendous. Beautiful. After President Kennedy announced plans for landing Americans on the moon by the end of the 1960s, it became immediately obvious to NASA that a follow-on program to Project Mercury was required to develop the techniques needed to support these future missions to the moon. NASA announced the second manned human spaceflight program known as Project Gemini in January 1962. Gemini would act as the bridge between the Mercury and Apollo programs, with the key objectives of demonstrating the endurance of astronauts and spacecraft for the extended duration spaceflight required to fly to the moon and back. Flights to the moon would take over a week to complete. And so one of Gemini's main aims was to establish the ability of humans to withstand long-duration space flight to understand the physiological effects of spending that much time in a zero-gravity environment. Project Gemini would also develop techniques for rendezvousing and docking, spacecraft in orbit, refine atmospheric entry and splashdown procedures so that specific landing sites were reached, and perfect the art of spacewalking. If an astronaut is to walk on the surface of the Moon, they must first leave the safety of the spacecraft. Gemini astronauts were the first to train for these specialist spacewalks. Gemini was one of the pathways to the Moon, and the whole point of getting outside the capsule and performing a spacewalk is that it was known that that would be necessary. Learning to operate outside the spacecraft was an essential component of getting to the Moon. It's an essential component of what we do now with the space station. It always will be. EVA stands for extravehicular activity, which means the astronaut is working outside of the confines of the spacecraft in essentially free space. It was critical as a part of the preparations for the lunar landing, because one of the main objectives of the lunar landing is to work outside of the spacecraft, to leave the lunar module and work in the lunar surface environment. It was also very important to be able to leave the spacecraft in the event that any repairs were required. So the ability of an astronaut to leave the confines of the cabin and to retrieve material or to fix problems on the outside of the spacecraft, while clearly it was hoped that that would never be necessary, it was important to show that that was possible. The first NASA mission to attempt an EVA was Gemini 4, the second manned mission of the Gemini program. Gemini 4, flown by astronauts Jim McDivitt and Ed White, was assigned the task of proving that the US were gaining on the early progress of the Soviets' music using Project Gemini's new launch vehicle, the Gemini Titan II rocket. McDivitt and White left Cape Canaveral on June 3rd, 1965, 56543210. Ignition. Liftoff. We have a liftoff at 16 minutes after the hour. Climbing very nicely. Music. We have a roll program initiated. We have staging, and it's been confirmed here on the ground. Thrust looks good. Thrust looks good on the second stage. And McDivitt, in a very, very calm voice, said it looks great up here. I want to bear Jack. After their third orbit of the Earth, Ed White opened the hatch of the Gemini capsule and made history, becoming the first American to walk in space. Okay, I'm graduating from the spacecraft. My feet are out. Okay, I'm out. Music tethered to the spacecraft, Ed White floated free 200 meters above the Earth, traveling at 17,000 miles per hour. Okay, I'm coming over. You see me yet? I feel like $1 million. This is the greatest experience. It's just tremendous. The footage of Ed White's EVA is one of the most recognizable and iconic set-off images from the early period of the space program. Up until that point, the astronauts had been seeing everything either through periscopes in the early days of the Mercury program or from quite small cabin windows. And here was an astronaut opening the door in orbit and moving out into free space, where his view of the Earth and the spacecraft was completely unobstructed. All he had was a large visor through which he could get the full vista. It was such an inspirational thing, phenomenal achievement, and to be honest, a brave one. If you imagine you open the door of the spacecraft and you get out, that was a fantastic thing to do. Ed White's EVA was proof that the United States was catching up with the early Soviet successes, and that NASA training and hardware was capable of winning the space race to the Moon. However, NASA's first spacewalk didn't go completely to plan. A communications problem meant that Mission Control could not establish radio contact with Gemini 4 for the majority of the EVA. Gemini 4, Houston Capcom. Gemini 4, Houston Capcom. Ground Control were very concerned because the astronauts were losing track of time. The people on the ground were frantically trying to get a signal to the astronauts to terminate the spacewalk. Flight controllers were concerned that if Gemini 4 didn't keep to the mission timeline, astronaut White could find himself walking in space on the night side of the Earth. In total darkness, it would be extremely difficult for him to maneuver back to the safety of the capsule. Gemini 4, Houston, Capcom. Applause! Gemini 4, Houston, Capcom. Finally, Jim McDivitt noticed and fixed an incorrect switch configuration in the capsule that reopened communication channels with Mission Control. And as he did that, Jim McDivitt said, we better find out what Capcom think, see what the flight tracker's got to say. Capcom got the signal, and the immediate response was the flight director says, "Get back in. This is Jim. Got any message for us? Gemini 4, get back in." Okay. So the audio coming from Capcom, it's essentially mission control, telling the astronauts to stop playing about and get back into the capsule. "Roger, we've been trying to talk to you for a while here." "No, back."
Come on, I'm coming. Okay.
Ed White's EVA lasted just 23 minutes, but NASA learned a very important lesson about how humans operate in the vacuum of space. NASA discovered that EVA is difficult. Working in that space suit, which is very constraining, is really exhausting. And the subsequent Gemini EVAs all led to the astronauts returning to the capsule in a really overheated, exhausted state. It wasn't until 8 Gemini missions later that astronaut Buzz Aldrin, who would later walk on the moon alongside Neil Armstrong, conducted the first fully extensive EVA. Gemini 12, Houston Capcom 1-minute EVA record. Beautiful job. His success was attributed in large part to his experience as a scuba diver. Aldrin pioneered the technique of underwater neutral buoyancy training, which simulates an environment similar to working conditions found in space. Project Gemini flew 10 manned missions between 1965 and 1966, firmly putting the United States ahead of the Soviets in the Cold War space race. And the neutral buoyancy training developed during Gemini remains an integral part of the astronaut training regime to this day, responsible for the success of every NASA EVA to date. NASA's first close-up observations of the planet Mars were conducted by the Mariner and Viking programs during the 1960S and 70S. These historic missions gave us our first views of the mysterious red planet, both from orbit and down on the surface. The exploration of Mars could be considered one of NASA's greatest achievements. The early period of its exploration, from 1965 to the late 1970, saw NASA achieve the first landing on the surface of Mars of 2 laboratories that extensively analyzed, trenched, and photographed the surface at 2 separate sites. After the early pioneering missions of the 60S and 70S, there was a hiatus in the American exploration of Mars. Only in the early 1990s did NASA begin developing a new program of landers and rovers that could work across the Martian surface to visit multiple sites. We'd seen with Apollo how the lunar roving vehicle had been able to move around various areas of geological interest around a common site. We wanted to do that with Mars, get it mobile, not just have a lander that sat there but could move on. And it's centrally coincidental with the human spirit. You climb one hill, you see another and want to climb that. And that's what these rovers are capable of doing. After almost 20 years, NASA finally returned to the Red Planet in 1997 with the Mars Pathfinder mission. Pathfinder's goal was to cost-effectively deploy the first free-ranging wheeled robotic rover down on the Martian surface, with the mission carrying a suite of scientific instruments to analyze the Martian atmosphere, climate, and geology. After a 309 million-mile flight through space, the Pathfinder spacecraft arrived at Mars in July 1997. But in addition to its scientific objectives, Pathfinder was going to test a new and innovative descent and landing system, the approach that was used to try to successfully get not just a lander, but a rover onto Mars. If you'd have read about it in books 10 years earlier, you'd have said, this is crazy. This is science fiction. If Pathfinder could successfully demonstrate this new technology, it would forever change the way scientific probes are deployed down to a planet's surface. The spacecraft enters the Martian atmosphere at 4 miles a second. It heats up to more than 1,000 degrees centigrade, but slows the spacecraft down enough so parachutes can be deployed. Mars's atmosphere has got such a low density that even with these huge supersonic parachutes, it's still moving faster than a car speeding down a highway. Music. So, the final stage for landing. The lander and the rover were cocooned within a huge assembly of airbags. Music, when Pathfinder impacted with Mars. The first thing it did was bounce. Music. In Mars's much lower gravity, those bounces continued. There were more than 1.5 in total. And then finally, when the spacecraft came to a standstill, it only had a matter of hours of battery power for it to deflate its airbags, turn it the right way up. If any chain in that link had failed, then this mission would have been consigned to the scrap heap. And we need to remember that when it comes down to Mars, less than half of the missions at that time that had been dispatched to the Red Planet had resulted in success. And so a tremendous amount in terms of new technology hinged on the success of Pathfinder. Now down on the Martian surface, the Pathfinder lander opened, releasing the rover to begin its scientific investigation. Mars Pathfinder was the first rover exploration of the Martian surface. The Pathfinder lander itself landed in a place called Ares Valley, which is in the northern plains of Mars. And then a small rover rolled off and explored the local rocks and soils around the landing site. The data returned by the Pathfinder mission has started to really unlock our understanding of Mars's geological past. The chemistry that it measured of different rocks revealed insights to Mars's past volcanic history and actually provided us with new insights that Mars had a diverse range of volcanoes in the past, right through from eruptive lavas like we see on Earth in places like Hawaii and Iceland, but also far more excitingly that it had a more evolved form of magmatism, possibly related to more explosive types of volcanic structures. And this was really unexpected for the Martian surface. Pathfinder wasn't DESI. And that has been followed by an extraordinary new level of capability with the 1-ton Curiosity lander Music that lowered on a sky crane is the new way we will be sending big landers and rovers to Mars. And in Archive, a copy of that vehicle with different instruments will gather up samples and leave them at a location that a future lander will visit for returning to Earth. And that itself will be precursor to the first human footprints on the Red Planet, which could easily come in the 2030s. What we really need with Mars is to take a geologist there because the rover can see what it can see, but it can't make decisions in real time. A human, a geologist on Mars will be able to do exactly that. If you take, for example, the Apollo 17 mission where Harrison Schmitt was a geologist and went to the moon, what he was able to do much better than a robotic system can do was to be able to say, actually, we don't want those rocks there. There's a rock that we should be investigating. There's a rock that we should take back. There's a sample we should take back to be able to make real human decisions in real time. But the missing link that made our modern rovers possible was the Pathfinder mission. What a tremendous legacy to have. What NASA achieved in that magical summer of 1997, deploying for the first time a Martian rover, really paved the way for the successes and the future explorations that the agency is currently planning for the Red Planet. Exploration rovers deployed on the surface of Mars continue to rewrite the scientific textbooks on our understanding of the Red Planet. But it is clear that what NASA started in 1997 with the Pathfinder mission will ultimately culminate in an international human expedition to set foot on Mars. Music. During the early 1970s, it became increasingly apparent to NASA and the larger scientific community that much more needed to be known about the 4 outer planets that dominate our solar system: Jupiter, Saturn, Uranus, and Neptune. If more could be understood about these gas giants, it could unlock secrets to the history and formation of our Earth and the solar system. Exploring the solar system in which we live enables us to understand more about how our own Earth was formed. We are intrinsically part of that solar system. So therefore, we need to understand more about the planets that surround us. We need to understand more about how we fit in to this incredible part of the universe. To understand our position in the evolution of the solar system, let alone the galaxy, we needed to get out there beyond the asteroid belt and really get to grips with what those planets were about. That was Voyager. As originally conceived, the Voyager program was a sequence of missions that would see a fleet of spacecraft exploring our outer solar system. But due to budgetary concerns, the program was downsized to the 2 spacecraft mission of Voyager 1 and Voyager 2. However, this plan to explore the deepest, darkest, and most inhospitable regions of our solar system would need to take advantage of a favorable alignment of the 4 outer planets that would not occur again until the 22nd century. The Voyager program, the Voyager missions were only possible because of an incredibly fortuitous coincidence that our ability to design and build spacecraft and launch spacecraft coincided with an alignment of the planets that would not occur again for another 176 years. that would allow the spacecraft to fly by planets and use the gravitational energy of the flyby to increase the velocity of the spacecraft and change the trajectory, change the direction in which the spacecraft was moving in order to encounter another planet. So it was almost like a game of planetary billiards. This favorable planetary alignment would occur in the late 1970s and allow NASA to harness gravitational assistance to slingshot the two Voyager probes from one planet to the next. Exploiting gravity in this way not only reduced the need to carry large quantities of fuel, but also had a huge impact on the mission timeline. Without the gravitational flybys that this alignment made possible, it would have taken 30 years for the Voyagers to reach Neptune instead of 12 years, which was ultimately possible. Although coordinated and designed by NASA, the Voyager program was a highly collaborative venture, with many scientific institutes and university research teams across the US providing scientific instrumentation. Music launched a few weeks apart in the summer of Mars. Iten Jobat Sishatsi, the twin probes of Voyager 1 and Voyager 2 set sail for their one-way tour through our solar system. After 18 months, the Voyager spacecraft arrived at Jupiter in 1979. The Voyager program really transformed our view of the solar system. And at Jupiter, Voyager showed us the first ever active volcanism at a place other than the Earth, with Jupiter's innermost moon, Io. And there were some interesting features observed in the imagery taken during that encounter. Those features were analyzed, and they were found to be the signature of an enormous volcanic plume rising from the surface of this extremely turbulent moon off Jupiter. It's really one of the landmark discoveries. The dynamics of the famous Great Red Spot, this enormous storm that has a size equivalent to that of the Earth, was studied in great detail. Music, the Saturn encounter, was arguably the most photogenic of the Voyager program. Voyager provided an immense amount of detail on the ring system of the planet, and one of the most famous discoveries that Voyager made at Saturn was the existence of what are known as shepherd moons. In the outer ring system of Saturn, there are two very small moons which were moving on either side of these rings. And these became known as the shepherd moons because the gravitational influence of those moons actually shepherds those particles into a stable orbit and makes the existence of these rings possible. After the encounters at Saturn in 1980 and 81, the two Voyager probes part company to follow two very different trajectories, and Voyager 1 diverts to investigate Saturn's largest moon. Titan is a very interesting moon. It's a very enigmatic moon. It was known from ground-based observations that this largest moon of Saturn had an atmosphere which was very rich in methane, and methane is of great interest in terms of the ability of a moon or a planet to sustain life. But a consequence of that was that the trajectory would take the Voyager 1 spacecraft out of the plane in which the planets move, and therefore Voyager 1 would not be able to encounter Uranus and Neptune. However, Voyager 2 continues on its mission towards Uranus and Neptune. In contrast to the magnificent ring system that had been observed at Saturn and the incredible atmospheric dynamics that we saw at Jupiter, Uranus itself, the planet, was actually rather featureless. The real star of the Uranus encounter was that the planet has quite a significant magnetic field, and the structure of this magnetic field is very unusual. It has a corkscrew shape, something that isn't seen in any of the other planets. And this is one of the most important discoveries of Voyager in terms of the planet itself. Voyager 2 has its final planetary encounter with Neptune in 1989, the outermost of the gas giants and the most distant planet in our solar system. Neptune came as a complete surprise. The atmosphere was found to be very dynamic. It had this glorious blue color, which had been hinted at in telescopic observations from the Earth. What really wasn't expected was the amount of activity in the atmosphere, the existence of a dark blue storm very similar to the Great Red Spot of Jupiter, the existence of auroral features on Neptune, the existence of nitrogen geysers on Neptune's largest moon, Triton, which has a surface that is the coldest surface anywhere in the solar system. Music. So, after the rather mixed results from Uranus, the observations of Neptune were a complete surprise. But Voyager's farewell to the planets wasn't the end of their mission. On their trajectories, it was only a matter of time before both Voyager spacecraft would leave the solar system. And in August 2012, 35 years after it was launched, Voyager 1 became the first space probe to pass into the region between the stars known as interstellar space. Voyagers 1 and 2 are now leaving the solar system. They're the two man-made things that are the furthest away from Earth of anything that we've ever made. They're literally going through the boundaries of the solar system into interstellar space, which doesn't sound like a big thing when you're used to Star Trek or Star Wars or whatever, but to actually leave the sphere of influence of the sun, leave the place we live in that way, is actually a fantastic achievement and is the beginnings of us exploring the rest of the universe. That to me is iconic. It's a major step. It's impossible to overstate the significance of the Voyager mission. Voyager really put our solar system in perspective, but I think one of Voyager's major contributions was the way that it allowed us to put our own planet, the Earth, in some form of context. Because it's not until you observe the objects around you and you see how different they are to our own planet that we really begin to understand the formation and the significance of the place that we call home. But perhaps Voyager's most significant and long-lasting contribution to our sense of who we are is the family portrait photograph, looking back at our solar system and our family of planets. In amongst this photographic data is one frame with a tiny little blue dot, which is partly obscured by a light, little sunbeam coming through the camera. And that blue dot is the Earth, and it's where everything that you know is. Everybody, everything that has taken place in history is in that little blue dot. And I think that will probably be one of Voyager's lasting legacies. Music the Voyager program has given us a deeper understanding of our place within and what exists beyond our solar system. And in the 40 years since its launch in 1977, it continues to explore and enrich our understanding of our place among the stars. Named after the great American astronomer, the Hubble Space Telescope is one of the largest and most versatile scientific instruments ever put into space. Originally conceived by NASA in the late 1960s, Hubble was built to answer one of the biggest questions in astronomy. The Hubble Space Telescope is a unique instrument. It had some particular science goals, and one of the major ones was to learn more about how far away distant galaxies are, and as a result of that, work out more accurately how old the universe was. By placing the telescope into Earth orbit, Hubble could overcome many of the limitations of ground astronomy and peer deeper into the universe than ever before. The telescope was built because of this need to try to get instruments outside the Earth's atmosphere to improve our view of the universe. It's very difficult to do observations that are very precise from the ground because the atmosphere gets in the way. Movement in the atmosphere makes images less sharp than they would be if you could view things from space. So being up above the atmosphere gives you this absolutely unrestricted view. But also the atmosphere blocks some of the important radiation that astronomers like to use, such as ultraviolet light and infrared light. So Hubble gives us access to a much broader spectrum of light than we can see from the surface of the Earth. Beginning in 1978, NASA, an international collaboration with the European Space Agency, to design and construct the most sophisticated space telescope ever built. Complete with 400,000 components and 26,000 meters of wiring, Hubble was carried into orbit by a space shuttle in 1990. Close and lock your visors, and you all have a good trip. We are go for main engine start, 5, 4, 3, 21, and liftoff of the space shuttle. Discovery with the Hubble Space Telescope, our window on the universe. Roll program, Roger, roll, discovery. The telescope was deployed at an altitude of 380 miles, the space shuttle's highest orbit to that date. You got to go for HST deploy ops. That's outstanding. Thank you. First glimpse, the space telescope looks like it's in great shape. Roger that. Thank you. Now, outside the distortion of Earth's atmosphere, Hubble will unlock secrets to the universe no one could have imagined. Music Hubble has rewritten the astronomical textbooks in so many ways. We've all seen the spectacular images that have been sent back. We've seen areas where stars are being created, the Pillars of Creation image in the Eagle Nebula. We've seen what happens at the end of stars' life when we look at the supernova remnants. And we've seen wonderful images of entire galaxies, island universes, collections of billions of stars. And you ask 100 different astronomers and you get 100 different favorite Hubble images. The Hubble Space Telescope has been incredibly successful. It was designed for 7 years of life, and here we are more than 3 times past its design life. It has a very large mirror, so it's a very large collecting area on the telescope, and that's how it's able to see so far into the depths of the universe. The Hubble has a range of different kinds of camera on board that are designed to record the images that we all come to know and love. But they also have instruments that record spectra. That is, they split the light up into its various components. And that allows you to probe deep into objects and determine things like temperature and pressure of the gas around them. Hubble is the only space telescope designed to be serviced by astronauts while in orbit. Between 1993 and 2009, 5 space shuttle missions repaired and upgraded the telescope to keep it equipped with cutting-edge technology. Because of the shuttle's ability to go up to Hubble and fix it, but also take up new technology, it's been possible to convert Hubble into a 1970s designed spacecraft and telescope into a 1990s, 2000s designed spacecraft. So one very good example of that is that there is a small patch of sky where when Hubble was launched, there wasn't a single star visible. 7 years later, they took up a new camera to Hubble and they looked again at that area of space to see if they could find any stars. Known as the Hubble Deep Field, the image that was captured is perhaps the most significant of Hubble's career. The Hubble Deep Field is a very, very long exposure, and the Deep Field was the first attempt to look as far out into the distant reaches of the universe as it's possible to go. Hubble was tasked with looking at what seemed to be a blank field of sky. It was in the constellation of Fornax, and in terms of size, this was a size of sky smaller than a 1 millimeter by 1 millimeter square, drawn on your thumb and held out at arm's length. What Hubble did on more than 800 orbits is look at that same patch of sky again and again and again, catching more and more photons, and it was an exposure time of nearly 1 million seconds. What emerges are 10,000 dots, but those objects weren't stars, they were all galaxies. And a typical galaxy has 200 billion stars. For me, this is the most mind-blowing image that's ever been taken in astronomy. The impact of the deep field is particularly remarkable because you can see all these faint smudges of light that are galaxies that were being born before our own solar system and galaxy ever existed. Using that image and using high school science and maths, you can make a meaningful estimate of the number of stars in the universe. And Hubble has shown us that what we read about in textbooks is absolutely true. There are more stars in the universe than there are grains of sand on every beach on planet Earth. And so Hubble's insights have been scientific, but they've also been cultural. They've been human. The Hubble Telescope is responsible for capturing some of the most detailed deep space images ever taken, with many observations leading to breakthroughs in astrophysics. It's hard to quantify the contribution that Hubble has made. In particular, it's helped us learn about the age of the universe. We didn't know that very precisely before Hubble was launched. And now we can say the universe is about 14 billion years old, give or take a little bit. And that's a major advance. But it hasn't just given us information on that. We can now study planets orbiting other stars and even examine their atmospheres using the instrumentation that's on board Hubble. We never even knew that these planets existed when Hubble was launched. You realize 2 things. First of all, how vast the universe is and how many stars, and therefore potentially how many planets, and therefore what the chances of life are evolving somewhere out there. And the second thing is that you realize how small a part of the universe we are. We assume we contain all the knowledge in the universe on this planet. And maybe we do, but the chances of something else evolving out there are so much greater now. We know just how many stars there are. Now, when Hubble is replaced by the James Webb Space Telescope, that spacecraft, that telescope, is 1,000 times more powerful than Hubble. So imagine what we're going to see in 2018, 2019 from that new spacecraft. I would challenge you to find anybody who is not blown away by the sheer beauty that we see in the Hubble images. It's what taps into what it is to be human. We have this innate desire to understand our universe. And although there are other space telescopes, Hubble for me has set the gold standard. The biggest contribution of Hubble, I think, has been to inspire and light up the public imagination as to what lies out there. How exciting it is, how wonderful astronomy is, how beautiful the universe is, how extraordinary, humbling it is to sit and look at pictures from light years away of objects and structures light years across. And in a world that's struck with its own deeply incisive and divisive concerns and difficulties, lifting our spirits to the wonders of the heavens can be a greatly satisfying pastime and something to turn to that just lights up a whole new understanding about what we are as human beings. Music, 37 minutes. Whether meeting manned spaceflight milestones or spearheading deep space research, we've seen how NASA is pushing our technological and intellectual boundaries. In part 2, we'll explore how NASA sustains life in Earth orbit. The Angle has landed and faces the challenges of sending humans to the moon and beyond. Music, music,